Hello, my name is John Snyder with Anderson Engineering. I'm going to continue with the field classification of the visual manual methods, and we're going to prepare another sample. This time it's for the wet shaking test, or what we call the dilatency test. It's the ability to measure how water comes out of the sample. So again, we get the soil, we prepare it, we passed it through the number 40 sieve. We took out all the gravel, big pieces, the sand size, and we basically let in anything that was sugar size or number 40 sieve, salt size, or smaller, we let pass through. So we got the sample, and we added water to it and got it to mix a little bit more than damp, but not wet and not moist. Moist, it would be wet in our hands, we could be able to see it. Damp, we can feel it. We're somewhere in between. So it does leave a little bit of moisture, so we'll take a sample about golf ball size. Grant Thomas will do the other one. So we're just going to mix it. And just so it's a thorough mixture. And then we'll just make a little meatball, a little round golf ball shape. And then we'll set that aside and demonstrate the test later. You got yours, Grant?
Yep.
Very good. Thank you. Good morning. My name is John Snyder with Anderson Engineering. It's day 2, and we're going to continue our field classification test. This is the second test. This is called the latency test. It's very useful for telling if we have silty materials. We're going to take we took the golf ball size, we got it moist, and we're just going to add a little bit more water just so we can shake the water out. So I added a little bit more, and now I'm just going to mix it up. It's just a little bit past moist. So we make a small pat, might take this into 2 pieces. So there's no moisture on the surface, and I'm going to strike my hand. And when I strike it, you can see this surface right here is called livery surface. So you can see a slight sheen because we got water on it. I'm going to go ahead and do it again, and I'm just going to mix in the rest of the sample. So we're going to go ahead and make it big enough that it can kind of stay more secure in my hand. You can see right there, no moisture. I strike it on the side, and we can see we have water came out. And that's kind of, it looks like a liver, so we call it livery surface, or livery appearance. And when I remold it again, we lose the moisture. So because that had a reaction and that water came out, we know that's a silt. So now we're going to do the same test on the sample we thought was a lean clay. So I'm just going to add a little bit more water. This is moist. I'm just going to add a little bit more just so I know water can come out. It's a little bit wet, so I'll just dry my hands. I make it into the pat. So we got a pat right here. And because it's a clay should be able to hold on to water more and not be able to come out. So you can see here, there is no reaction, no water. So we know that's a lean clay. Now here, this one's a fat clay. You can see just by squeezing it, it was moist, but it is hard. I'll put a little bit of water in it. Just to prove, and one thing with fat clays, we'll cover that in the rolling test, but they are very tough even at the same moisture. So here we got, and no reaction, no water coming out. So that concludes our dilatency test, or wet shaking test. We had no water come out, so we know that we had the silt where we had a reaction, and the lean clay and the fat clay, we had no reaction. Thank you.